Final video of chapter 6 functions. Let's go. We're going to jump right into this. So we start off with scope. Chapter 2, we visited this idea of scope and we really explained it as simply the area of your program where a given variable is understood. And when we gave an example, maybe you have up here on line 3, we say x equals 5, whatever that is. And what that means is, what's the scope of x? Imagine your program has thousands of lines of code, or maybe hundreds, or maybe 86 lines of code, and the program ends right here. What was the scope of x? The scope of x was from the line it was defined on until the end of that overall block that it was defined inside. Now here, x is not defined in any block of code. So the scope of x is from line 3 all the way down to 86. But had x been instead defined in a block of code, maybe we had, this was some type of an if statement. If, I'll just make it, let me give an x up, let's give a y. If, or w equals 5. If w equals 5, here we say x equals 4, and maybe we have 20 more lines of code all the way to here-ish or so. End of if block. Now, if block. So now what is the actual scope of x? The scope of x is from line 5 to where it was defined until the end of that if block. Line 22 is how I've defined it. Meaning if on line 24 we were just printing hello, then that means that this if block would have been all the way from lines 4 to 23-ish or 22. And so the scope of x was from the line it was declared on, line 5, all the way until the end of that block. That is the overall idea of scope. But now we're going to look at scope within the context of functions. Variables that are created inside functions are called local variables, and even parameters are considered local variables. When you send an actual parameter over to a function, and that parameter, that actual parameter, gets saved where? Into the formal parameters that we've called placeholders. Well, those formal parameters are considered local variables. They're local variables that belong specifically to that function in question. Local variables, they can only be accessed within the function that they are defined in, or within the function that they were sent to, if it was a parameter that was sent to that function. The scope of a local variable is similar to the scope as we've just seen with traditional variables, variables that are not part of a function. And the scope of a local variable, it starts on the line that the variable was declared on, and it continues to the end of the function that contains that variable. Therefore, the scope of a formal parameter is going to be from the very beginning of the function all the way to the end of the function. Now, Python also has what is known as global variables. These variables are created outside of all functions and they are accessible anywhere. In fact, since we've most recently just covered functions, and prior to functions we were just putting variables right here in our program, x equals 4, y equals 3, z equals x plus y. Well, guess what? All of these variables were actually called global variables. These are examples of global variables because these variables here are not inside any function. If I were to make a main function, and inside this main function I make an a equals 3, b equals 6, and then c equals a plus b for whatever reason, well, these variables a, b, and c, these are all examples of local variables. They are local to this particular function. But these variables up here, x, y, and z, they are not part of a function, right? They are not inside any other function, and these are called global variables. So it just happens to turn out that the variables we've been using ever since the beginning have been global variables. Now, global variables are accessible anywhere. You might think, well, that's easier. They're accessible everywhere. Why not just use them? Because appropriate programming practice is to use local variables and limit the use of global variables. And there's some nuances and important reasons for that, which we'll cover in just a bit. So examples of local and global variables are what we're now going to cover, many separate examples. Here's the first. Notice that we have on line 1 this global variable that is set equal to 1. That's just the name of the variable. I called it global var equals 1. Then we have this function. The function is function f1. Inside this function, we have a variable called local var. It equals 2. Then we have 2 print statements. And then on line 7, we call the function. On line 8, we print global variable. And then on line 9, we print local var. So let's go through this and see what happens. If we were to be the Python interpreter, we're trying to play that role of the Python interpreter. So the first thing it's going to see, okay, you have this variable called global var. It equals 1. Great. Then Python says, cool, you got a function. Great. It just, the interpreter sees we have a function, but it doesn't do anything with it. But now on line 7, oh, you want me to call that function? Gotcha. So we go to the function, we call it, and we see local var equals 2. That's a variable inside the function. It's a local variable. So we had this variable called local var. It equals 2. And then on line 4, we print global var, or global var. So we're going to print 1. Line 5, we print local var, local variable. So it's going to print 2. Pretty straightforward, right? It's going to print 1, and then it's going to print 2. But now what happens on line 8 and 9? On line 8, we print global var, or global var, however you want to pronounce that. And so we're going to print 1, right? Line 8 is going to print this value, global variable. But now look at line 9. Line 9, when we try to print local var, what's going to happen is Python's going to say, I don't know what local var is. What is local var? And you're thinking, well, it's right here on line 3. No, on line 3, that was a function. When we called that function, then and only then was local var understood, and it was equal to 2. But when that function closed, guess what? The activation record for that function closed. That function is no longer on that function call stack. Local var no longer exists. And so on line 9, when you ask Python to print local var, Python will cop an attitude, it'll shout at you in red, and give you an error. So this is the overall idea with that one. Here's another example. X equals 1. Python interpreter says, okay, got you. Define some function. Cool. Python's like, got you. We come to line 6. We call this function. All right. Well, when we call this function, what's the first line of code inside that function? It says x equals 2. Then we print x, which you would expect would display 2. But now look at line 7. After the function, we display 1. What's going on here? How can we understand that? Do you already make sense of it? Perhaps. But let's go through this. This variable on line 1 is a global variable, right? It is accessible everywhere. Now on line 6, when we call this function f1, look what happens on line 3. We say x equals 2. What's really happening there? We're not modifying that global variable x. You might be thinking, yeah, we had x as 1, now we're setting it to 2. We are not. That's not what's happening. On line 3, we are making a new variable, a local variable, inside this function, and we're setting that local variable x equal to 2. So when we print x, we're printing the value of this local variable. Once this function finishes, and we come to line 7, and we now print x again, what gets printed here is the global variable x, and therefore it prints 1. Because when this function finishes, what happens? The activation record is removed from that function call stack, and this local variable x, which equals 2, no longer exists. This is the idea. So x is declared twice, but the first time is as a global variable, and the second time is as a local variable, local to this function f1. Another example. Here, if I have on line 1 this global variable, we don't have any functions here. I have this global variable x. We say eval input enter a number. The user enters a number. If that number the user entered is greater than 0, on line 3, we create a new variable y and we set it equal to 4. And now on line 5, we print y. Well, this program will work if the user enters a positive number, right? If they enter 12, is 12 greater than 0? Yes. Therefore, y equals 4. Line 5, print y. It will print 4. But what if the user enters 0, which is not greater than 0, or if the user enters a negative number? This if statement will no longer be true, right? A negative number is not greater than 0. Therefore, we will not execute line 3, which means, as a consequence, y never came into existence. So when we try to print y on line 5, yeah, Python's like, what are you doing? Talk to me. Y is not even a variable that exists. So because y is created conditionally only when line 2 is true, this means this program will produce errors on the instances when the user enters a negative value or 0. Another example. All of these are just the overall ideas of scope as well as local and global variables. Here we have x equals 1. We have this function increase, which does something. And now we as the Python interpreter, we see that we're calling this function increase. Cool. What happens? When we call this function increase, notice we have here x equals 1. Then we say x equals x plus 1. So now what does x equal? X equals 2. And then we print x. Of course, it will display 2. That's pretty straightforward. But now, after we're done with that function, and after we've therefore called this increase function, what's the next line of code? It says print x. What happens? We print 1. Pretty, again, straightforward. But after we then print 1, we print x, which displays 1, seems pretty straightforward, but maybe that's a bit confusing here, because didn't we just increment x and didn't x become 2? Why is it now only displaying 1? This is similar to that previous example, because again, this x, even though it's the same name, this is a global variable x. This here is a local variable x, local specifically and only to this method or this function increase. So when we increase that x and it becomes 2, then we print 2, and when we finish, when we print x here, what's actually happening? We're printing the original value x, which was 1. So the local variable x is different than the global variable x. This is the takeaway. That increment that happens, the increment inside the function does not change the global x. It only changes that local variable x. So here's a question for you. What if you have a global variable and you would like to modify that global variable inside your function? How can you do that? Like here we have this global variable x. What if we want to modify that global variable x inside this function? How do we do that? Could we just say x equals x plus 1 and we don't even put this local variable x? We can't do that. That won't work, but we're close. So how do we make that happen? What you do in Python is what you see here. Inside the function, we type global space x. What does that do? What that does is it effectively binds this usage, any usage inside this function of the variable x. It binds that usage to the global variable x that was defined outside the function. So by typing global x right here, what it really does is on the next line, when we say x equals x plus 1, now the Python interpreter says, oh, you're talking about the global variable x. I got you. And so here, when we increment x, we're actually incrementing the global variable x. So we're going to print x, which displays 2, and then after the increase function has completed, we print x. It will still display 2 because inside this function, we actually incremented the global variable x. So some brief checkpoints. What is the output of the following code? Here, and pause the video and try to do this on your own. Now that we've covered those as samples, try to answer this on your own and then come back for the explanation. So here we have a function. I'm going to be the Python interpreter. We have a function. I'm not even going to look at the function right now. Now I'm going to simply look after the function. I see x is 2. It's a global variable. Y is 4. That's a global variable. And now I'm going to call this function and I'm going to send to it the value. I'm going to send to it x, which is basically 2. I'm not going to overcomplicate that. I'm not going to say we're sending the address of the object 2, which is on the heap, and then we can access that address and get the 2. That's unnecessary to say. For the purpose of this problem, I'm just going to say that I'm sending over x, which is 2. So let's now evaluate the result of this function call, and we send over 2 to right here. So x is now 2 inside the function. Remember, this formal parameter is now a local variable. So we print x, it will print 2. Now we're changing x to 4.5, and we're changing that local variable x to 4.5, not the global. And now y, we're assigning it to 3.4, and we print y, and y will be 3.4. So what did we print thus far? We printed x, the parameter we sent over was 2, then we printed 3.4. Now, outside the function, we're going to print x and y again, and when we print x, we're not printing this value 4.5 because that was a local variable inside the function. Instead, when we print x, we're going to merely print 2, and then we print y, and it will print 4. And that is the correct output. And so let's look at another one now. What is the output of this code? This is not related to any of these scope problems. This was just here, and I thought it was valuable. It was one from the publisher, and it's something we haven't completely covered. So here we have a function. This function has 3 parameters. And note that while the 3 parameters are listed as x, y, and z, notice that these parameters are also given a value. We have really, inside this function, we say x, then we say y equals 1, and then z equals 2. What this is Python. It's very strange. I don't recommend you even use it often or ever, but Python allows you within your function header to not only specify the formal parameters, but Python also allows you to give these formal parameters default values. So here we're saying that the default value of y is 1, the default value of z will be 2. X has no default value. Now simply what this means is when we call the function, I don't even need to send over a y or a z. And if I don't do so, what that means is y will have a default value of 1, z will have a default value of 2, and we need not even send that value over to the function. But if we send a y and a z over to the function, if we send all 3 parameters, then the values that we send to the function will overwrite the values that are already there as default values. So let's go through these examples. Here, we're calling the function f, and we're sending over 3 values. 1 goes to x, this 1 goes to y, and this 1 goes to z. So z will no longer be 2, z will be 1. And so when we return x plus y plus z, 1 plus 1 plus 1, we will return a 3. Now when we look at this one, here we're calling the function again with 3 parameters. This time we send, and notice, now we're using the keyword based parameters. So now I was about to say we're sending 1 to x and then 2 to y. That would have been a mistake. Notice, because since we're using the names, the order does not have to strictly matter. Instead, we match up the names. So 1 is being sent to y, so nothing changes there. 2 is being sent to x, so now x has the value 2. And 3 is sent over to z, so z will not equal 2, the default value. Instead, it will equal 3. So we sent over the values 1, 2, and 3. Of course, you add them together, you get 6, which is correct. And then finally, we have this last example. We're sending over 2 parameters now. The first parameter automatically will go to x. Y is not named, so therefore it will not get an updated parameter, and its default value is still 1. And z, we're sending the value 3 as an actual parameter. So x is 1, y is 1, z is 3, 1 plus 1 plus 3 is 5. Kind of strange, but I left this here. I was about to delete this slide, and I was like, you know what? Maybe there's a value, at least to be aware that you can do this in Python. And then I tell you, but don't do that in Python. Not something we really want to do often, but it's important if you see that code to understand how it works. What's wrong with this code? Pause the video, try to figure out what's actually wrong with this code, and then we'll come back and we'll discuss it. So to answer this question, simply put yourself in the role of the Python interpreter. Let's go through it step by step. Line 1, we see a function. Got you. We have a function. No big deal. Line 7, we now call that function. Cool, let's go to the function. We have a local variable x, it's 4.5. A local variable y, 3.5, no problem. Now we print x, we print 4.5. We print y, 3.4. Pretty easy. We come to line 8, and now line 8 says print x, and I hope you already see the problem. Same thing on line 9, print y. That's a problem. What's the problem here is once this function finishes, it's removed, its activation record is removed from that function call stack, and that function ceases to exist, which means any local variables we made in that function, they cease to exist. So on line 8, when I print x, Python's like, are you sure? Like, are you sure? There is no x. Maybe it's better for a big brain one. Python's like, you want to rethink that. The error is the scope of x and y are strictly here within the function, and when the function closes, they cease to exist. All right, time to solve a problem. We only have one coding exercise that I'm going to do with this video, and then we're going to end talking about function abstraction and stepwise refinement, 2 new terms. But this here is a big problem. Wait, I got ahead of myself. That's on the next slide. I got too excited because I want to code. Here, returning multiple values. This is pretty quick. Just one more slide. Simply letting you know something cool that Python allows you to do. Something cool is that you can return not one, but multiple values from a function. And why is that cool? Most other languages don't allow you to do this. Most languages allow you to return one thing. Python, you can return multiple things. So here's an example where we have this function called sort. You send to this function 2 numbers. It checks if number 1 is less than number 2. If so, it returns number 1, comma, number 2. Otherwise, if number 1 is not less than number 2, it returns number 2, comma, number 1. So we're actually returning 2 things. So notice on line 7, this is an assignment. On the right side of the assignment, we call this sort function. We send over a 3 into 2. So the 3 comes to number 1. The 2 comes to number 2. Is 3 less than 2? It's not, so that's false. So we come to the else, and what we return is number 2, comma, number 1. So we actually return the number 2 followed by the number 3. And so when we return those 2 values, notice we have on the left side of the assignment, we have n1, comma, n2. And so the number 2 will come right to n1, and the number 3 will come to n2, and we can then print them out. Just a unique feature of Python where you're allowed to return multiple values. All right, let's go. Here's the problem, finally coding time. We want to generate random characters. In particular, we want to generate 175 random lowercase letters and print them 25 per line. To be honest, if you're wondering why, I agree. This is not the most valuable program as far as you're not going to want to be generating random characters all the time, but it's a great program to practice this idea of modularization. We're going to offload some of these functions into another file, and it's another program that allows us to make a more vanilla style function, and then we're going to make more specific versions of that function that we'll call the vanilla version, if that makes sense. I think it makes sense. We'll go through it and it'll make sense. So we want to generate 175 random lowercase letters, and we want to print them 25 letters per line. Kind of funky, but the value is as I already described. So always we'd start with the problem solving phase. How do we print a random letter? That's what we want to do, right? We want to print a random lowercase letter from A to Z. Well, how do we print a random letter? Or more generally, how would you print a random character? Pause the video if you like, think for 15, 20 seconds. How would you print a random character? Well, if you remember that, I say here you need to import random. Sure, great, import random. But what else? If you remember that we have ASCII, right? And that every character is in fact mapped to an ASCII equivalent, and we have this unique ASCII value from 0 to 127, printing a random character really amounts to what? It amounts to generating a random number between 0 and 127. I'm going to come over here to garbage. Let me import random. And if I just say some number equals random.randint 0, 127, let's print some number. That'll just print out a given number. 58, run it again, 55, run it again, 46, run it again, 73, got a 0, and then one more, 89, right? That's just a number. Well, how does that help us? Well, if we can generate that random number between 0 and 127, that was ASCII, so 128 possible numbers. Now we can use the character function to obtain the integer value from that randomly generated int. Full disclosure, I paused the video there because I read that and I was like, that doesn't make any sense. We use the character function to obtain the integer? No, that's a typo. We use the character function to obtain the character value of that randomly generated int. So what do I mean by that? If I come over here and I type print CHR some number, that was a function, this char function, we saw that like way long ago on the maybe chapter 3 video. So what does it do, this char function? Remember, every single character, how about I give this value? X equals, I don't want to delete, let me delete all of this real quick. X equals, I think it's 97. Print the char of X. What's that going to actually print? It's going to print the lowercase letter a. So remember that every character has a mapping to a binary equivalent, and 97 is the decimal value of the binary equivalent of what this lowercase letter refers to, this lowercase letter a. So A is 97 in decimal, or 97 in ASCII. Not a big deal. You don't need to memorize that, but it's just a fact. So I'm just reminding you that all of these letters, these characters, they map to this ASCII table. They have a binary equivalent as well as we convert binary to decimal, therefore a decimal equivalent. So if we take any of these values, let me come back to here, paste, and now we print this. We've generated a random number from 0 to 127. We print that number, and now we want to print the character value of that number. So 117 is you, 20 is that thing, 105 is I. I'm going to run a few more. 126 is a tilde. 33 is the exclamation point. 94 apparently is the shift 6. 84 is a capital T, and so on. So now we have generated a random number from 0 to 127, which is that ASCII table, and we are then using the char function to convert that value to its appropriate character value from the ASCII table. Okay, so how can that help us now? Because the goal is what? To generate this 175 lowercase letters. Well, we're on our way. What can we do now? What about random lowercase letters? Well, one solution is just to remember the actual ASCII values of lowercase a through lowercase z. And if I'm going to be honest, ain't nobody doing that. You may remember 97 because I just showed it to you, but is anyone going to really remember that z is 122? No. Better yet, hell no. Ain't nobody remembering that. Okay. But if you did, you could come back to the code and you can say, you know what? Let's create a random number between 97 and 122. So we're always going to be generating a lowercase letter. That's interesting. Okay. Kind of cool. Maybe. I don't know. What else? So that would work, but no one wants to remember that. So we could use Python's built-in ORD function, another function that we likely forgot about because we haven't used it. Let's be fair, if you're not using it, you're not going to remember it, right? What does the ORD function do? The ORD function returns the ASCII value of a character. So right now, what are we doing? We're generating a number and we're using the char function to get the actual character. Well, the ORD function goes in reverse. If I say print out the ORD of this character A, what is it going to print? It's going to print 97, right? So the ORD, it goes in reverse. So here we have, if I just wanted to print out the char value of 97, that will print the A, right? The char value of 97 prints A, and the ORD value of A will print 97. Kind of interesting. Or the char value of 65 versus the ORD value of capital A. And I happen to just remember that because I've done it enough times, right? So 65 is the decimal value of the ASCII value for the lowercase letter A. Sorry, the uppercase letter A. So 65 and A. So if I print the char of 65, that will give me capital A. If I give the ORD of capital A, that will give me 65. So the other idea is, for those who don't want to remember all those nuances, we could use the ORD function to return the ASCII value of a particular character. So now what we need is a random integer between the ORD of A and the ORD of Z. So instead of a random integer between 97 and 122, no one wants to remember that. What if instead we say, give me a random integer between the ORD of A and the ORD of B. Does that make sense? Oh, not B, Z. So the ORD of A is 97. The ORD of Z is 122. And a random, so this is now, all of this right here becomes 97. All of this right here becomes 122, and we have the exact same thing. So hopefully that's clear. So no one wants to remember that 97 is lowercase a, 122 is lowercase z. So instead we can use the ORD function to convert a to 97 and convert lowercase z to 122. So we have randent the ORD of a to the ORD of z. And now we can simply get the character value of that, putting this all together now. And let me just make a print statement. So here, if I did a print statement, let me delete all of this other stuff. So if I just printed this, I'm just generating a random number from 97 to 122, right? Well, what if I take all of this and I put it inside the char function? So now, after I generate this random number, I want to put it in the char function to convert it to a character. And there we are. We are finally generating lowercase letters from A to Z. I was going too fast. Okay. P, A, H, E, and so on. Cool. So that's what we have. And so a random character between any two characters can be made as follows. This is interesting. So we can make a function define get random char between, let's call it char1 and char2. And this function, we're going to simply do this. Notice we're going to take the char of a rand int from ord of char1 to the ord of char2. So I'm going to highlight all of this. The ord of ch1 and here to ch2. Return that. Let's see if that makes any sense at all. And here I want to print, I'll do it in two steps. The character we generated, to make it super clear. That's the variable name. I'm going to call this function get random char. Let me change it to character. Get random character. And I'm going to send over to this function two parameters. What parameters? I'm going to send over an A, and I'm going to send over a Z. So the A is going to come right here. The Z is going to come right here. And then, of course, if this, think about it, if this became the A, then, of course, this becomes the A. This became a Z. That becomes a Z. And then, of course, this becomes a Z. So it's really, we're doing the exact same thing, but now we have a more vanilla function that we've made that allows us to send over any two characters, if that makes sense. But let's go ahead and print this. Print the character we generated, and let's see what we get. Here we generated a D, an O, an R, a J. Well, why is this now valuable? Because check this out. Let's now do this again, and let's send over, how about a capital A and a capital Z. Now, this capital A is going to come here to character 1, and it's going to come here as well. And the ord of capital A is 65. And then we're going to send over capital Z, which is going to come right here. And so now we're generating a new number between 65 and whatever Z is. I honestly forget what Z is. So, and now we're generating a capital letter, a B, an E, a K, a G, and so on. Cool. So this gives us a chance to practice modularization. Let's remove the functionality of generating these random characters from the program that actually prints them, and let's make a program containing only functions. So then we're going to make the program that actually prints out the characters. So here is, I'm not going to go type all of this, but this was the idea. Notice here's this very vanilla get random character function. And so now we could also make another function, define get lowercase letter. Let's call it get random lowercase letter. And here I'm going to type return, and I'm going to call the get random character function, and I'm going to send to that function A and Z. And I'm going to make another function called, how about get random uppercase letter. And here I'm going to send a capital A and a capital Z. Okay, so this is all currently in garbage. So let's paste this over here and let's save this. And what do I want to call this? I want to call it, I'm trying to see, random characters. Cool. So I'll call this random characters.py. Let's save this in chapter 6, save. So now I have this set of functions saved into this file randomcharacters.py. I'm now going to make an actual program to print 175 lowercase letters. Not very creative for the name of this program. And I want to import random characters. So that's going to import everything from here. It'll import all three of those, right? And so in order to use any one of them, I'll have to first mention the name of the file and then mention the function I want to use. Kind of like when I import random, right? I have to first say random.randint. If I did not want to have to say random, I could have instead, I would have said from random import randint, if I'm doing that correct. Let's see. I could have done this, in which case I don't actually need to even type random.that, and that would have worked as well. But we're used to typing random.randint, right? So in that same vein, here, I'm going to type import random characters, and now I can use those functions. So the functions that we have here, let's go ahead and just test it in print one. Let's call print random characters dot get lowercase letter, just to test to see if it works, that we're doing the right thing. So no, we're not. Or did I misspell this? Random underscore characters. I think I have a misspell, a typo. I don't see a typo. Ah, I see it. Yes. This is saved into a particular folder, chapter 6, and here I was heedless and I did not save that into the same folder. So therefore it can't find that file I'm trying to import. Now it's in the correct folder, and now when I run it, and I still have a typo. What do we have now? Get lowercase letter or letters. Get random. I didn't type it correctly. Oh my goodness, it's great that you can see fails. I love it. Okay, get random lowercase letter. There we go, finally a J. So those weren't actual errors, that was just I put it in the wrong file and then I typed the wrong name. So we're importing random characters, right? So we're importing everything from this other file. And what is everything? Well, we really have three functions. How do I now use that function or use any of those functions? I have to first give the name of the file, the module I'm importing, then I put a dot, and then I mention the function. Cool, that allows us to practice modularization. What's really remaining on the problem? Well, here's the code. I won't go code it up because of time, but what really remains is we're just going to loop 175 times, and we're going to print out that random letter every single time and only put a new line after every 25. So pause the video, look at this solution if you need to. The main purpose of this problem, though, was to cover everything that we just did. The idea of putting these functions over in a file, practicing modularization, and then calling that function from this other file, while also the idea was important to practice of making this more vanilla function, and then we're calling that vanilla function and sending to it specific values, lowercase a and z, to get a random lowercase letter, uppercase a and z to get an uppercase letter. Also, the other one that these made was define get number. And here we could then call this same function, and we could send over a character 0 as well as a character 9, and it will return to us a number between 0 and 9. All right, so last thing is just to cover a couple of slides. What is function abstraction? This is really the main idea for developing software. Developers need to be comfortable with function abstraction, which is what? It's the idea of separating the implementation of a function from the actual usage of that function. Because when the customer, the client, they ask you to make a function, they don't need to know the inner workings of how it actually, how it operates. They don't probably want to know that. They simply want it to work. You want your phone to work, your computer to work. You don't need to know the inner workings of all of the code that goes into the operating system that you're using. You just want it to work. Those details are hidden, in this case, from you, the client, the user of your phone or the user of your computer. And this is called information hiding as well as encapsulation. We're trying to hide those details from the user because frankly, they don't care. They just want it to work. The client, They have access to the function header. That's what they need. They need to know what they're going to send to the function. And then that function, they expect it to return some result to them. That's all that's important. And so we have this idea in computer science of a black box, where the function is this black box. When the reason we call it that, meaning that we don't need to know what are the inner workings of that box. All we need to know is we're going to send to that function parameters. That function is going to return to us an answer, some results. What actually happens in there, that's up to you. That's up to the developer. This is the idea of function abstraction, because now we can separate the solving of those particular problems from the usage of those functions that solve them. And we end with here stepwise refinement, which is the idea of solving a larger problem by breaking it into smaller and smaller components. Because clearly, if you're given a huge program and say, go do it, well, that's kind of challenging. But if you can break it into smaller components, especially if those smaller components can take advantage of function abstraction, and we can offload certain components of this program into functions, absolutely makes your life so much easier. And it makes your program easier to debug, easier to modify, easier to maintain. Because if you've broken down maybe 800 lines of code into maybe 5 or 6 different functions of 100 lines of code each, well, now you can debug those functions independently, individually. You can make sure that, okay, that function, I know it works. And that other function, I know it works perfectly. But here's the error, it's on this function. Well, now you can isolate the debugging and the error checking and the error fixing to the functions themselves, and it makes your life so much easier by isolating those errors. So whenever you're dealing with a large program, similar to the kinds of ones that I'll often give to students, you want to use stepwise refinement and function abstraction. You want to try to throw as much as you can into individual functions to therefore isolate maybe any problems that occur to those functions. And then once those functions are ready and are working correctly, you then put the entire program together. And guess what? Let's go. We are done with functions. Wow, have we come a long way. Basics of Python, selection statements, loops, functions. Y'all are ready to really go rock it. As always, reach out, ask questions. Take care, everyone.